All right, here's just a basic review on the three major things with the triangle. Okay, the first one we talked about was the circumcenter. I'm going to go through this quickly because we need to get to the actual problems here in a second. So how did we find the circumcenter? We found the perpendicular bisector of the three sides. So what does that mean? That means you bisect the sides. So it means you find the midpoint. I'm not going to be real precise with this. We'll just kind of eyeball it. That looks like the midpoint, and we draw a perpendicular line to it. All right. So that means that right there is a perpendicular bisector. We do that with all three sides. Okay, so how do you find the circumcenter? You find, or actually, how do we say? Let's say we draw. Okay, it'd be the easiest way to say it. We draw the what? Perpendicular bisectors of all three what? Of the three sides. Okay, so I take all three sides and I do the perpendicular bisector. It means I split it in the middle, so that point's got to be the midpoint, and we go perpendicular to it. I do the same thing with the other three sides. So I find the midpoint, looks about like right there-ish, and I didn't do the best triangle in the world for this, but that's okay. Let's say that looks kind of perpendicular right there. Alright, so that means that's equal to that. That's perpendicular. Now, what should happen if I did this right? I wasn't real careful with this, but it should be about, that looks like about the midpoint, doesn't it? And if I go perpendicular, it should go through the same intersection point as the other two went through. Alright, so that means this side and this side are equal. So what is that point where they all intersect? That's the what? That's the circumcenter. And there was something special about the circumcenter. What was special about this circumcenter? It was equidistant to the vertices. That's right. So these blue lines right here are all equal to each other. All right, so all three of those blue lines are the same. You got to study this, okay? We've talked about this on several occasions. You got to study it. I know it's, the day we got back from a long weekend and stuff, and it's not all fresh in your mind, but this is something you have to study. You have to look over this stuff yourself. Don't wait the night before the test. Don't wait 5 minutes before you come in to take the test. You need to go over this on several different occasions before you take the test, not just the night before. So these three blue lines right here are equal to each other. I'll put one tick mark, it's in blue. So all three of those are equal to each other. All right? They could ask all kinds of questions on this, couldn't they? They could tell you that this is 3 and they ask for this segment right there. What would that be? That would be 3. What would the whole thing be, this whole side? It would be 6. Okay, they could say that this is 7. And what is this blue line right here? That has to be 7. They could ask you all kinds of different things. They could put it in terms of x, couldn't they? They could say that, like, this is 3x plus I don't know, 6 or something like that. They say this blue one is 3x plus 6 and this blue one is 7, solve for x. What would you do? Set them equal because they're all equal to each other, right? All right, so that's the kind of stuff that they're going to ask you to do for circumcenter. Enough of that. Let's move on to another one. Let's do, what was the second one we did? Was the second one centroid? Oops, why did I do that? Do you remember what the second one was? Wasn't that the incenter? I think the second one that we did was the incenter. Yep. So let's draw a triangle. And make it look a little different. Alright, how did we find the incenter? Do you remember what we did to find the incenter? What colors did we use? Let's stay the same color coordination. We used red. So let's take a look at this. What was it, Summer? What did we do? The angle bisector, okay? So what we did is we looked at the angle right here and we bisected the angle. We tried to split this angle into 2 equal angles. You're going to have to eyeball it because I don't really have a way to, I'm not going to measure the angle and then actually take a half of it. I'll just kind of look at it, and it looks like about there. And what am I looking at? I'm looking at these 2 angles right here. I'm looking to see if those 2 angles are equal to each other. All right, that's the angle bisector. Does that mean it hits the midpoint of the opposite side? No. It just means it bisects this angle. So these 2 angles will be equal to each other. I do that to all 3 angles. I did it to one angle. Now I do it to another angle. See what I'm doing? I'm looking at this angle and I'm trying to split it in half. All right? And that's pretty close. Maybe about like that. And then I do that to this one down here, and where should it intersect if I do it correctly? Should intersect right there at that point. That point is called the incenter. Now, what's special about that point? Remember, there's something special about all three of these points that we're going to do. On the incenter, what's special about it? It's the same distance, what? Not to the angles, because that was the circumcenter. It's the same distance to the what? Sides of the triangle. So that distance, that looks about the same distance. We'll go like that, and we'll go like that. See those three blue lines right there? If it's the distance to the side, we make it a right angle. So all three of those blue ones are equal to each other. Again, how did we find the incenter? We found the angle bisectors. All right, you need to review this. And if you don't like looking in the book, and if you don't like looking at the notes, go to the computer and put on the YouTube pages, and I'll go through that whole entire thing again. In fact, there's probably a lesson in there somewhere where I review that again. All right, this is probably like the third time that I've actually done a complete review of these three things right here. So there's no excuse not to know these. You've got to put some extra effort into it. All right, if you just sit there and if all you rely on is you just sitting there watching me do this in class, it's not going to be enough. I promise you it won't be enough. You've got to do stuff on your own. If you want to do better, and if you haven't been doing as well as you think you should be doing or you want to do, then things have to change. What has to change? Well, you're going to have to study more. You're going to have to review the lessons on the YouTube more. You're going to have to look at your notes more. You're going to have to do more problems. You're going to have to make a change. If you don't change, your grade's not going to change. I promise you it's not. You can't just sit there and, oh, I hope I do better, I hope I do better. That's not going to do anybody any good. You have got to do better by studying more yourself. All right, enough of that. Let's do the third one. What was the third thing that we talked about? What word was that? That was the what? The centroid. Now, how did we find the centroid? By the way, I didn't do this up here. How did we find the incenter? We would draw what? The three. I said it, but I didn't write it down. What? How did we find the incenter? The three what? Angle bisectors. Right? Said it half dozen times just on this part right here. The three angle bisectors. That's how we find the incenter. Now, how do we find the centroid? What do? We draw the what? Does anybody remember that one? We draw the three, starts with an M, medians. But you got to know what that means, don't you? You got to know what the word median means. So let's put a triangle in here. We'll just do a regular basic looking acute triangle like we've always been doing. All right, and how are we going to find the medians? You got to know what that means. We go from the vertex where? To the midpoint of the opposite side. We're not necessarily bisecting this angle right here. We're looking to the other side. We're trying to hit it at the midpoint. Now, it's not perpendicular to it, is it? Because that would be finding the circumcenter, the perpendicular bisector. That right there is the median. It's the median because this and this are equal to each other. It starts at an angle and it goes to the midpoint of the opposite side. I'm not going to make you draw it, but you need to know. If I have the word centroid, you need to know what it means. If I say that this is the centroid, you have to know that this segment and this segment are equal to each other. You got to know that that you've found the median of this side as well. All right, so I'm not going to make you draw the things. But the word centroid will be on there. The word circumcenter will be on there. And you have to know what they mean and what the special thing is about this, okay? So what did I do? They all three intersect, don't they? And that's what's true about all three of these things. They all intersect at the same point. It means they're concurrent points. And we found it by finding the median. Find the median by going from the vertex to the midpoint of the opposite side. All right, that right there is the centroid. Well, there's something special about this centroid. Do you remember what's special about the centroid? Remember this centroid? It splits this line segment. Does it split it in half? Does it cut it in half? It doesn't cut it in half. It cuts it into thirds, okay? This cuts it into thirds. This is 1/3, and this is how many thirds? This is 2/3, right? So the longer one is 2/3, and the shorter one is 1/3, which means the longer one is twice as big as the shorter one. Hear what I said? this longer one. And how do I know which one the longer one is? The longer one always goes from the vertex to the centroid. Said that many, many times. You got to write it down. You got to say it over and over again. You got to write it down yourself. From the centroid, or from the vertex, sorry, to the centroid, that's the longer one. The longer one is twice as big as the shorter one. And the rest of this is the shorter one. So, if I said the BC was 5, you should very easily be able to tell me what AB is equal to. Remember, this is twice as big as this, right? So what's twice as big as 5? 10 is. Agreed? Yeah. So that's easy. That's the easiest one. If I give you the short one, finding the long one is super easy. What if I told you to find the length of AC? What would AC be equal to? It'd be 15, right? Because I found the short one. Well, they told me the short one. Found the long one. The whole thing is 15 because you just add those two up. That's all there is to it. Some people are just getting way too confused on this, but this one is actually kind of easy once you realize that the short one is half of the longer one, or the longer one is twice as big as the short one. All right? What if they gave you this? What if they gave you that as 12? Could you find BE?
6.
Yeah, because they gave you the longer one, right? The longer one went where? From the vertex to the point in the middle, right? The centroid. So if that's 12, this is the shorter one, that's got to be 6, right? The longer one is twice as big as the shorter one. It's not hard, is it? The longer one is twice as big as the shorter one. If you can remember that, you should be able to do these. And then what would DE be equal to? That'd be 18, all right? What if I gave you this? What if I gave you that A, B, C, D, E, F, G, right? What if I told you that FG was equal to 21? And then I ask you to find FB, and I ask you to find BG. Remember, the shorter one is 1/3 of the whole thing, right? The longer one is 2/3 of the whole thing. I think it's easier to do the 1/3. Okay, do the shorter one. If I told you the whole entire thing, watch, FG, I told you that whole thing right there was 21. And I ask for this little one, and I ask for the bigger one. Find the little one first. What's the relationship? It's 1/3 of it. How do I take 1/3 of something if I know the number? Just divide it by 3. We've talked about that many, many times. This is not the first time you've heard this. So you take 21 divided by 3. What is 21 divided by 3? 7, thank you. So that would be 7. All right, so the shorter one is 7. Well, what do you think the longer one's going to be if the shorter one's 7? It's going to be 14. That's all there is to it. That's the hardest one. Out of all the problems that we do, that's the hardest one. And that's not even that hard, is it? You divide by 3, and that's 7, and that's the shorter side right there. You've got to look over it. You've got to look over it. Look, can you not tell that I want you to do well? If I didn't care, would I even be going over this stuff again? No, I'd just read off the answers, give you another assignment, say whatever, who cares? But I don't feel like that. I feel like I'm more invested in this than you are sometimes. Some of you guys, it seems like you couldn't care less. Seems like I care more than you do. You should be caring much more than I care about your grade, okay? And about, not even your grade. I don't even care about the grade part. It's the learning the material. I want you to learn the stuff, okay? Not just to get a grade, all right? I mean, a grade's an indication if you learned it or not, but it's not what I'm really concerned about. I want you to learn it. Learn it for the sake of learning, okay? Enough of that. Let's do an actual problem here. So let's take a look at, well, goodness, number 3, we basically did that. We basically just did that. But let's look at it the way they write it, because maybe you understood what I was saying, but then when you see the problem sitting there and staring at you, and they give you all these letters, then maybe that gets a little confusing for you. So let's try to straighten this thing out. Here's the thing. Now it says point E is the centroid. So I'm going to draw the thing for you, and it tells you it's the centroid. So that tells you something about where these lines hit and all that kind of stuff, knowing it's the centroid. Now we just finished talking about the centroid, so this should be fresh in your mind. Let's put the letters that they use. They go A, B, C. This is number 3, by the way. Number 3 on that worksheet that we're we're going over. And that's F and G and E right there. Okay? Now, let's read it. Everybody looking at the worksheet? Let's read it together, and this is what you should do when you're doing this problem. So if you didn't get this right, if you had no clue what to do, I'm showing you from scratch how to approach this problem right here. It's already drawn out for you. You didn't have to draw it yourself. They put a D in here as well, don't they? Let's put a D right there. Okay, now let's go back to yellow. All right, let's see what we're going to do here. It says, if point E is the centroid of triangle ABC. Well, here's triangle ABC. It says point E is the centroid. That tells you some stuff already, doesn't it? If that's the centroid, these lines that go from the vertex to the other side must hit at the midpoint. So I know those two are equal. I know these two are equal. And I know these two are equal. All right, so by knowing the centroid, I know that stuff. What else do I know? Well, I know that the shorter side is half of the longer side, right? Or the longer side is twice as big as the shorter side. So let's put some numbers in that they tell us. What do they tell us? They tell us that BD is equal to 12. BD, that's that whole thing. BD is equal to 12. If you don't like that thing drawn inside the triangle, if you think it's too messy, you don't have to draw it. Just come up here and put BD is equal to 12. But visually, you're going to have to understand that that thing is 12. What else? And we'll deal with this in a second. What else do they tell us? EF, right? So EF, where's EF? This little bit right here, and that's 7. And then AG is 15. That's another one. I'll tell you what, I'll do this in another color just so that, what color? Let's go green. So, what is it? AG, right? That whole thing right there is 15. All right, and the question says, find ED. Where is ED? This one right here. That's what we're trying to find. Everybody see that? Trying to find that line segment. Well, does this 15, does that AG have anything to do with this line segment right here? No. Nah, so I can almost not even worry about it, right? Do you agree? All right, it's got nothing to do with ED, so let's just get rid of it. It's kind of in the way. It's kind of a mess. There we go. So now what am I trying to find? I'm just trying to find ED. Well, what did they tell you? Did they tell you something? Yeah, they tell you the whole thing, right? They tell you the whole thing is 12. Well, what do I do? Is this the longer side or the shorter side to BD? What is it? Talk to me. It's the shorter side, right. How do I find the shorter side if they tell me the whole thing? Divided by 3. It's a third of it, right? So I take 12 and divide it by 3. 12 divided by 3 is 4. So what's ED? It's 4. It's as easy as that. They made it pretty easy, didn't they? Right? They don't ask for a whole bunch of other stuff. Now, they did tell you some other things, maybe to fool you a little bit, right? They told you this was 7, but did that 7 have anything to do with this? Nope. Didn't have anything to do with it. So I could have just got rid of it if I wanted to, right? But they could have asked you some other stuff, couldn't they? They could have asked you EC. What if they asked you EC? What would that be? 14. It'd be 14, right? Because it's just twice as big as the short one. Now, remember, they did tell us AG was 15, didn't they? So what do you think you could find if they told us AG was 15? EG is a third of that, so that's what? 5, and then what's AE? That's 10, right? There's all kinds of stuff they could. What if they told you that AF was 4, and they asked for AB? If they said AF was 4, now they don't do this on the worksheet, but I'm just saying, if they did. If this was 4, then what is AB equal to? Are you looking at it? Everybody see it or not? Yeah. It's what? What is it? AB. I'm looking for AB. AB would be 8. Because look, this would be 4, wouldn't it? Because it hits the midpoint. So the whole thing, right, they're equal. That's why this is 4. And then AB is 4 plus 4, which is 8. All right? Now, they don't ask you that on the worksheet, but they could, couldn't they? There's all kinds of stuff that they could have asked you here. They only asked you one thing, but you could have found all kinds of other stuff. And you never know what's going to be on the test. You don't know if they're just going to ask for this little bit, given the whole thing, just not sure. All right, so you got to be ready for anything. All right, let's do one of the other ones. I'll tell you what, let's do number 5. Number 5 is really easy. We just have a couple minutes here, so let's do an easy one. And then tomorrow we'll do maybe some of the other ones. Might be a little bit more difficult. By the way, so I don't forget, I'm going to give you another practice tonight, and this is from the book. All right, and it's called Practice Test. It's at the end of the chapter. So everybody write this down. So this is your homework. This is something that I will collect. It's page 381. It's practice test, and it's all of them. It's 1 through whatever. I didn't write down the numbers. I usually do that. I didn't this time. But anyway, it's page 381, practice test. It's usually like 1 through 20 or something like that. I'm not sure exactly what the numbers are. You can look and see yourself. Now remember, we did skip a lesson on that indirect proof. So if you see anything that says proof or indirect proof, you can just skip those. I don't know exactly which numbers they are, but you can look at that yourself. Okay, it's 1 through 25. All right, so there are a few on here that you probably will be able to skip. And you use your judgment on which ones you can skip. All right, so that's going to be your homework. But let's go over one little problem. Let's do number 5. Number 5 is pretty easy. And let's put some stuff in here. This is P and Q right there. This is N and M. Here's number 5. You're not packing up, are you? I didn't think so. So look at this. This is 2x minus 10 right here. And this one right here is x plus 15. And what do they tell you? They says that if PO is an angle bisector of angle MON. That's an O, not a Q. Why did I make it a Q? Don't know why. That's an O. All right, it says this right here is an angle bisector of angle MON. So what does that tell you? That tells you that this angle is what? Equal to this angle. So again, Lonnie, say it again. You said it. Set them equal and solve for x. That's right. Equals x plus 15. Now, look at the problem. What's it say? It just says solve for x, doesn't it? Right? But I could ask you to maybe find, now they don't do this on the worksheet, but I could ask you to find an angle like NOP. What if I asked you to find angle NOP? This angle right here. Plug it back in, right? You solve for x, plug it back in, and find whatever this is. Let's do the math real quick. We got a minute here. Probably less than a minute, but subtract x. What's that? X, add a 10. You got to know this algebra. If you don't know this algebra, then you're sunk. That's 25. And then that's what they ask. They just say solve for x. What if, though, I asked you to solve for this? You could put it into here, right? 2 times 25 is what? 50? 50 minus 10 is 40. So that's 40 degrees. Agree? I could ask you that to find this. Now, they don't in the worksheet, but I could ask you that. All right, do that practice test tonight. I'll read off the answers tomorrow. We'll go over that. And, yes, I do want that worksheet from you, that 2C worksheet. So turn it in to me before you leave.